Okay, I hope things are going well for you guys. We got 4-3, day 3 for PreCalc. Now we're looking at trigonometric functions of real numbers, and we must use radians. Our units of input must match the real number units for output. You must be aware when you need to use radians or degree in your calculator. And remember, you can flip between them under your mode. I think it's the third spot down in your calculator, and you just arrow over and highlight the one you want. I guess that's really my biggest concern. And a little reminder, if someone ever clears your calculator, or if your battery ever decides to die on you, automatically after the recharge, your calculator goes back in the factory specs, the way it was when you got it out of the box. And that is in radians immediately. So make sure you're aware of that. Now, we're going to talk about the definition of the unit circle. The unit circle is a circle of radius 1 centered at the origin. Now, I've been alluding to this quite a bit, and there's a couple things I want to go through. So arc length along the unit circle corresponds exactly to radian measure. The unit circle can be used as a kind of number line using a wrapping function. Now, with that said, in your Schoology, I want to make sure you guys see this again. I showed this the first day. It's in your Chapter 4 folder, What is a Radian? And I was asked a couple times on it the other day, and we're going to open that up and let you see it. And what is a radian? Maybe we're going to open that up and let you see it. It's still thinking. So this is from GeoGebra. And you can, this is the progress of where it's going. That's your radius. Here's your circle. Now they're going to show you the length of a radian, wrapping on the circle. Now that is the length of 1 radian. Here's the length of 1 rad. Now this is 2 radians. And now we have 3 radians coming up. And you'll notice that there's a little itty bitty space, 0.14159, and then we go all the way around. So this is pi, this is 2 pi, pi is 180, okay? And we're short 0.28 as we go around. Now, if you're interested in seeing this again, you can speed it up, slow it down, and it is available in Schoology, just to make sure you've seen what is a radian. Now, with that said, we've got that as a wrapping function. So that's really what this section is, wrapping it to pxy, okay, and wrapping around this way. As we talk about that wrapping function, the distance from your standard position back to where we have our point P, how the number line is wrapped onto the unit circle. Note that each number t, positive or negative, is wrapped to a point P that lies on a terminal side of an angle of t radians in standard position. So because r is equal to 1 in the unit circle, our earlier calculations are even easier. Remember cosine theta? X over r, well, if r is 1, cosine is x. Sine theta, y over r, well, when r is 1, sine is y. And people are like, well, what do you mean? Our coordinates on the unit circle, okay, each one of our pi over 2, pi over 3, pi over 4 values all the way around the circle have an x, y coordinate value. They're considered the cosine is with x and the sine is with y, and that's why we have this right here, this section. Okay, when the trigonometric functions are applied to real numbers, they are usually called the circular functions. Now, before we even move on from this, I want you to get to page 29. Okay, page 29 in your notes. Let me make this a little bigger so I can get it all in the your view. Okay, this is the unit circle. Now, remember, it's 1 unit long, and so this is 1, 0. And then my pi over 6, or 30 degrees. Remember, I want you to remember the 30, 60, 90, and 45, 45, 90. In a 30, 60, 90 triangle, this is the square root of 3 over 2, and this is 1/2. Well, the square root of 3 over 2 and 1/2. This is my x, which is cosine. This is my y, which is sine. And it is my sine and cosine. If you're in degree mode, for the sine of 30 degrees, it's 1/2. For the cosine of 30 degrees, it's the square root of 3 over 2. For the radian mode, the sine of pi over 6 is 1/2. The cosine of pi over 6 is the square root of 3 over 2. And that'll work all the way around the circle. Your calculator will return decimals. It won't return an exact answer, but these are the exact answers we expect to use in calculations. I also expect you to be able to work with radians straight up without transferring them into degrees and vice versa. So you must be familiar with both. Now, to work around our circle, I got the square root of 2 over 2 and the square root of 2 over 2. For pi over 4, 45 degrees. Okay, I've got 60 degrees. Okay, look, this 60 degrees is in the same triangle that the 30 degrees was in. But I flip them because to get there, I have my triangle flipped upside down, or on its side, on a different side I should say. And this is the 60 degree angle, this is the 30 degree angle, this is my right angle. And I go out 1/2 and I go up the square root of 3 over 2. And then finally get to pi over 2, it's 0, 1. So those are my points for the first quadrant. Now, these points, these coordinates for the first quadrant are connected to all the other quadrants. So I've got pi over 6 here. We're going to work with pi over 6. This is 5 pi over 6. Okay, so as I'm working through, I got 5 pi over 6 over here. Well, to get there, I had to go negative square root of 3 over 2 and up 1/2. Okay, and over here, for the square root of 2 over 2 and the square root for pi over 4s, I go negative square root of 2 over 2 and positive square root of 2 over 2. And over here, 2 pi over 3, I go negative 1/2 and I go positive square root of 3 over 2. And then I go negative 1 and 0 to get out here pi. Now I want you to take this opportunity right now and pay attention to the symmetry and get the other two quadrants filled out with their coordinates. Please turn off the video to do that. Okay, welcome back. Hopefully that went well, but again, it's all about the symmetry and what's going on. I've got 3 pi over 2, it's 0, negative 1, okay? And I'm looking at 7 pi over 6. Well, 7 pi over 6 is just pi over 6 below, past pi, and it is negative square root of 3 over 2 and negative 1/2. And then I go 5 pi over 4. Well, 5 pi over 4, same area as negative square root of 2 over 2, and then down negative square root of 2 over 2. 4 pi over 3, look how they're connected. Negative 1/2, negative square root of 3 over 2. Okay, I hope those are going well. I hope you're able to find those coordinates. It's all about using the same numbers from that first quadrant and adjusting it around the XY coordinate axis. Now, if I'm looking at 11 pi over 6, I've got the square root of 3 over 2, 1/2 for pi over 6, so it's negative 1/2 for 11 pi over 6. 7 pi over 4, square root of 2 over 2, and down the square root of 2 over 2. 5 pi over 3, 1/2 down the square root of 3 over 2. Now, pay attention to how this is going. I've got some people that might feel a little overwhelmed about this, but really what it comes down to is this is the unit circle. This is the stuff I need you to commit to memory because you're not going to be able to look at it all the time. So you've got to be making sure that you can create it on your own from scratch. I would just have a blank piece of paper, draw the circle with the axis in it, and then start dividing it up by pi over 6s, pi over 4s, pi over 3s, and pi over 2s. Make sure you can find those coordinates and label everything. That's the best way you can do for yourself to learn how to do it. And don't just stop with kind of knowing. Make sure you know very, very, very well. Did I mention that you should know very, very, very well? The rest on page 29. We're going to use the unit circle to verify the following. The domain for theta is negative infinity to infinity. Remember, we can use multiple revolutions to get this done. No problem. The range of y equals cosine theta is -1 to 1. Well, let's think about it. Y is equal to cosine theta. Cosine of any angle, 1/2, square root of 2, square root of 3 over 2, 1, square root of 3 over 2, square root of 2 over 2, 1/2, 0, -1/2, negative square root of 2 over 2, negative square root of 3 over 2, -1, and it goes all the way down. It keeps repeating all the way until we get 0 again. Oh, that cosine doesn't get any bigger than 1 and doesn't get any smaller than -1. It just keeps oscillating back and forth. And for that same reason, the sine does the same thing. Okay. Now, going from 0 to 2 pi completes one full cycle of the circle, just like 360 does. The graph of y equals cosine theta can be found by plotting all of the points, theta x, from the unit circle, and the graph of y sine theta can be found by plotting all of the points, theta y, from the unit circle. And it's an oscillating function. Keep in mind what it might look like. I'll pull up a calculator to show you real quick. Okay, so I pulled up my calculator, and I've got the cosine of x and the sine of x. I've got to go to mode, because I want this one in radians. So I'm going to get in the mode here, and I want to make sure I'm in radians. I am in radians. Okay, and then I'm going to go to my window. And I don't want my window to be so incredibly large in my Y area, because I don't need it that big. We're going to go 2, and we're going to delete that, and we're going to go here. Max is 2, and that should be okay. That should be about 2 revolutions from both sides, so you can see what's going on with the oscillation of this function. Matter of fact, I think I'm not going to have the negative on this one. We're just going to go up here, and we're going to put it from the axis starting at -1, and we're going to graph. So you can see that's the first one. Okay, that's the second one. Cosine was first, sine was second. And that's your function, and it's an oscillating function. Keep in mind, cosine is even, sine is odd, because it goes through the origin, and it keeps repeating. And so that's going to be a useful thing for us in our future. Okay, so we've got an idea what that function looks like. And now let's go back in our notes, talk about our exploration. Okay, this works well as a group exploration. Get together in groups of 2 or 3 and explain to each other why these statements are true. Base your examples on the unit circle. Remember that -t wraps the same distance as t, but in the opposite direction. For any t, the value of cosine t lies between -1 and 1, inclusive. Okay, the x-coordinate of the unit circle lie between -1 and 1, and cosine t is always an x-coordinate on the unit circle. Okay, 2, for any t, the value of sine t lies between -1 and 1, inclusive. Same idea, the y-coordinate on the unit circle lie between -1 and 1, and sine t is always a y-coordinate on the unit circle. The values of cosine t and cosine -t are always equal to each other. Recall that this is the check for an even function, and that makes sense because this is cosine, and they're always even to each other because it is an even function. The points correspond to t and -t on the number line are wrapped in points above and below the x-axis with the same x-coordinates. Therefore, cosine t and cosine -t are equal, and we can say that is an even function. And for that same reason, the points corresponding to t and -t on the number line are wrapped to points above and below the x-axis with exactly opposite y-coordinates. Therefore, sine t and sine -t are opposites. Sine -t is equal to negative sine t, and that's an odd function. So we got to know that. And number 4, I kind of assumed I read that, but I didn't. The value of sine t and sine -t are always opposite of each other. Recall that this is the check for odd function. Now, we've talked about that, and let's get going here on 5. We're looking this over. We're going to skip problem 9, by the way. The values of sine t and sine t plus 2 pi, remember that's a full revolution, are always equal to each other. In fact, that is true of all 6 functions of their domains and for the same reasons. Okay, and that same reason is that those are coterminal angles. Since 2 pi is the distance around the unit circle, both t and t plus 2 pi get wrapped to the same point. Okay, coterminal angles. Okay, the values of sine t and the sine t plus pi are always opposite each other. I'm just adding pi, and they're going to be opposite each other in the cycle. Okay, the same is true the cosine t and t plus pi. Well, let's talk about a t and let's add a pi to it. And we're going to go back to 29 for a second. If I'm here and I add t plus pi here, that's pi over 3, and I should be down here. What happens to my sine and cosines? Well, they're opposite values, okay, for each of those, a pi away. And in this particular problem, it's going to be like that all the time. If I go here, pi away, they're opposites to each other, so pi away. But now let's see what that means in the problem. So we're on 6. The values of sine t and sine t plus pi are always opposite of each other. The same is true of cosine t and cosine t plus pi. And that is true. Points corresponding to t and t plus pi get wrapped to points on either end of the diameter of the unit circle. These points are symmetric with respect to the origin and therefore are coordinates x, y, and negative x, negative y. Therefore, sine t and sine t plus pi are opposites, as are cosine t and cosine t plus pi. Now in 7, the values of tangent t and tangent t plus pi are always equal to each other unless they are both undefined, which means they're quadrantal angles maybe. Let's look at that back at problem 29. So we're talking about tangent. Let's take the easiest tangents because we don't have to work too hard when we talk about pi over 4s. But this is a negative divided by a negative, positive, positive divided by a positive, positive, and over here, negative and a positive, positive and a negative. Okay. Now on this one, let's go back and check that question. On this one, I've got them to be the same. On this one, I got them to be the same. And this one, opposites, well, I'm going to get them to be the same. Just randomly picking stuff. I got 5 pi over 6, 11 pi over 6. Boy, they're going to be the same. And they're saying here in this problem, the values of tangent t and tangent of t plus pi are always equal to each other unless they are both undefined. Agreed. Okay, so that is here by the observation in 6, tangent t and tangent t plus pi are ratios of the form pi over x and negative y over x and negative y over negative x, which are either equal to each other or both undefined. Now in 8, the sum cosine t squared plus the sine t squared is always equal to 1. This is known as a Pythagorean identity, okay? And that's taking, remember, cosine is x, sine is y, that's x squared plus y squared, my coordinates to get to my point on the circle, and my hypotenuse is 1. And that is true in a biggest sort of way. So the sum is always of the form x squared plus y squared for some xy on the unit circle. Since the equation in the unit circle is x squared plus y squared equal 1, the sum is always 1. Okay. Now, let's talk about some periodicity. Sine and cosine functions have a period of 2 pi, and tangent functions have pi. These predictable, repetitive behaviors help us model behavior in the real world. Now, defining periodic function. A function y is equal to f of t is periodic if there is a positive number c such that f of t plus c is equal to f of t. Now we found that periodicity when we go for sine and cosine 2 pi or we go tangent just pi, it's the same. So keep that in mind as we're reading this. That's what they're referring to. For all values of t in the domain of f, the smallest such number c is called the period of the function, and that's period is when the function starts to repeat itself. This behavior also helps us to train ourselves when we cannot and or should not use a calculator. Hint, hint, hint. Cannot or should not, or gosh, everything in this chapter be comfortable with without a calculator. Now, here's the thing. In example 8, you're using periodicity. Find each of the following numbers without a calculator. Now, this looks overwhelming because the stuff we did before, but let's break this apart. I've got 57,800 plus pi over 2. Now, this, if I look at it, this is an even number of pi's. That's an odd number pi. That's even. That's odd. That's even. That's odd. That's even. That's odd. That's even. Okay, we can keep going, right? But we're not going to because we know that this ends over at 0 pi and then goes pi over 2 more. Okay, so look at this. This is going to go around an even number of pi's, and all the even pi's end up here. All the odd pi's end up over here. Now, I go pi over 2 more. Based on our unit circle, that's at 0, 1, that pi over 2 more. So now I have really the sine of pi over 2 is equal to 1. And that makes sense. And I could even change this problem to be cosine of every 57,801 pi divided by 2. It would be 0 for that answer. Now, let's talk about periodicity. When I'm looking at cosine of 288.45 pi minus cosine of 280.45 pi, I'm looking at this and go, the difference in these two angle radians is 8 pi. So let's break it down like this. Now, we found out by working with coterminal angles that if I have a value, say 280.45 pi, we have coterminal angles coming back to the same spot. 8 pi is 4 full revolutions around the circle coming back to the same spot. At that spot, the cosine of those two values is the same. So if I have a cosine of something that's the same minus something the same, we're going to have 0. Okay, so keep that in mind as we're looking at this problem. Now, let's look at this one. I have an odd number of rotations. I'm going to go pi over 4. I can look at this way too. I have a picture here, but well, eventually my angle is going to be here at 3 pi over 4. But let's talk about this way. If I have a picture here, and this sucker is up here at pi over 4. Let's talk about, I'm at pi over 4. I'm here at pi over 4. And I'm going to go an odd number of rotations later. Remember, this is pi away. That's an odd number of rotations. And then 2 pi. 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi, 9 pi, 10 pi, 11 pi, 12 pi, 13 pi, 14 pi, 15 pi, 16 pi, 17 pi. So all my odds are right here. This is odd, okay? But it's negative. I went the wrong way. So now let's do odd again. Maybe if I go negative, it'll be different. Well, this is 0, 1 rotation, 2, well, that's 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi. So it's going to be an even number of rotations to there, odd number of rotations there, even if it's negative. Wow. So I'm going to go an odd number of rotations from pi over 4. That's negative, and that'll be here. So it's going to be down here at negative 3 pi over 4. Okay? And that's where I'm at. Let's talk about it this way. If I look at this, this is a even number of rotations plus my negative 75. So if I talk about it like that, if I start here and I'm at an even number of rotations, an even number of rotations always ends here. So that's odd, that's even, that's odd, that's even, that's odd, that's even, that's odd, that's even. And I'm going to talk about 0.75 more from my even rotations, negative 3 pi over 4. okay? And that's going to be a 1. Because remember, tangent is sine over cosine, or in this case, y over x. So we just use periodicity to help us find answers without a calculator. At this point, we should be able to use reference triangles and quadrantal angles to evaluate the trig functions for all integer multiples of 30 and 45, or 45. And of course, their radian counterparts. And don't forget about 60. Hey, we already filled this out. This is the same diagram. It was in our notes the whole time? Wow, cool. Boom's such a nice guy. This diagram is given so that you can visualize all the trigonometry you are now able to do. Try not to use it as you are working through your homework. It is important that you know it really, 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 really well, okay? And to help us with that, what I'd like to do, you guys should have a piece of paper on the back of your notes that is, yeah, if you go to page 30 on your notes, I didn't have it on this. Apparently, I got rid of it. I'm not sure where I put it. So on the very back of your notes, I'm asking you to find the exact value of each trig function. And that's what I'd like you to do as part of your assignment for Monday. And you've got 6, 9, 11 questions to answer. And here's the challenge. Work with the work with the circle a couple times. Draw your own circle, okay? Draw your own circle. And after you get it drawn and after you get it done, I want you to give yourself an opportunity to do page 30 and see how well you do. Okay, do page 30, try to do it without referencing a circle. You can create a circle on the page if you'd like, but without referencing the circle to get your answers. And let's talk about it on Tuesday. When you get to class. Now, keep in mind, you will be loaded up. I hate saying it that way, but I will be giving you both reviews that we'll be doing for next week. And instead of having the test on Wednesday, we're going to slide it to Thursday. I hope things are going well, and thank you so much for all your work. Remember, if you've got questions, ask them. If you need to, we can go over some stuff and probably look at things from a different perspective, I hope, to help you understand it. But make sure that you're doing your work and checking it online, not doing it online. And I hope everything's very successful for you. Until next time in class, have a great time.